This is the one you're talking about.
Yeah.
Cool. So, selenium comes to the table with 6 electrons, right?
Uh-huh.
Oxygens both come to the table with 6 electrons, so you have a total of 18.
Yeah.
Right? Selenium's in the center, Se. O on either side. We've used 4 electrons in bonding, so we have 14 electrons left over, right? So I have 2, 4, 6, 8, 10, 12, 14. Oh, it is. Okay, cool. So, these are all of my leftover electrons, right? You cool with me?
Yeah, I have that.
Cool. So, now I need to do the octet rule, right?
Yes.
So, oxygen has 2, 4, 6, 8 electrons around it here. Same with the other oxygen, right? Selenium has 2, 4, 6 electrons here, right? So,
and you have to move it from oxygen, so selenium is an octet, which makes it 2. That makes sense.
So you're gonna need to have it like these.
Okay, so then it would be a triagonal pyramid.
So that would make the electron geometry trigonal planar, but the molecular geometry is still
bent or angle because it's the
bent.
2 double pairs.
Yes.
Okay.
Yeah.
So that's what I wasn't doing, was the octet rule for selenium, or however you say that, Se.
Yeah, no, you got it. Yeah. Yeah, so you want to make sure, I don't know if you have the lecture packet. Chapter 4. Yeah. So, this little checklist here at the bottom.
Position.
Right?
Okay.
So octet rule is first and foremost, right? You got to make sure you have the octet rule satisfied. Then the number of valence electrons, right? So if you accidentally change the number of valence electrons somehow, then you messed it up. And then there's a couple of other things to check on. Again, I don't know how far you've gotten in the lecture videos, but have you gotten to formal charges, that kind of thing?
I don't know, because we had we watched some of them from lecture or from lab.
Okay.
And I don't remember. I don't think we went through. I don't think I watched all of them.
Okay. So
he also gave us some lecture, but his lectures are confusing.
Cool. So there's one other thing. Okay, so we know that the octet rule is satisfied. We know that we have the right number of electrons, right? So the next thing we want to check is formal charge. So we check formal charge. Why is this sticking here? Yeah, we get it. Cool. Ah. Yes, thank you. Okay. Sorry. Okay, so the next thing we want to check is formal charge. Now, when I do formal charge, I like to draw in the electrons on the bond because it makes it a little bit easier to see. You don't have to do it this way, but this is just, I'm a really visual person, so this helps me. So what I do is I box off each of the atoms, right? And I want to look at how many electrons it came to the table with, meaning what were the valence electrons that it brought to this molecule. So for oxygen, how many valence electrons did it bring?
6.
6, exactly, right? So we have 6 electrons is what it came with, right? Now, directly around the oxygen in this little box, we have 1, 2, 3, 4, 5, 6, 7 electrons, right? So if we subtract that, we end up with a -1, which is the formal charge on this oxygen.
Okay.
Does that make sense?
Oh, yeah, so you just have to add that in.
Yes. Yes.
Okay.
So
and is that counts for your proper Lewis dot structures to have those charges?
yeah, you have to have them.
Okay.
Yeah. So then we want to check the other oxygen over here, right? So we know it also came to the table with 6 electrons, and it has 1, 2, 3, 4, 5, 6 electrons here.
Mm-hmm.
So that means no charge, right?
Yeah.
You with me?
Yes.
And then selenium came to the table with 6 electrons, and how many does it have here?
8.
Not total, just directly around it.
6. Right? 2, 4, 5, 6. Am I crazy?
1, 2, 3, 4, 5.
Oh, I didn't put a. How did I mine looks a little different. Because I only have one lone pair for selenium.
Selenium.
And then but you put a double bond on one of the oxygens.
Yeah.
But that should be the same, right? The same number.
So do you see what electrons I'm counting though?
Yeah,
so when
never
I'm
mind.
doing when I'm doing the octet rule, I'm counting different electrons, right? Not just the ones that are directly around it, but all of the electrons that are around it, right? So the octet rule, I want all of the electrons that are surrounding it, right? For formal charge, I'm just looking at who's in this little box.
Okay.
Okay? So if we start off with 6 electrons and we have 5 electrons, that means we have leftover 1, right?
Mm-hmm.
Which means this has a +1 charge.
Okay. I haven't done that for any of them, so I guess I need to go back.
So the other thing that you'll find is sometimes you'll draw a structure and it's technically correct, but you could have a structure that has less formal charges. That's a better structure.
Okay.
So that is what we're talking. When we're talking about that, we're referring to charge minimization. So charge minimizing is saying if we can have a structure that has less charges and still obeys the octet rule and still has the correct number of electrons, then that structure with less charges, less formal charges, will be a better structure. And the reason being is because we know that negative charges, that's a good one, negative charges and positive charges are going to be attracted to each other, right? So this negative charge here represents an extra electron, right? And so if you have an extra electron over here and not enough electrons over here, what's going to happen?
They bond.
Yeah, you're going to form another bond, right? You're going to that electron's going to want to go over there. So what we could do is see, all right, maybe there's a better structure where we put another lone pair into a double bond, right?
And so you're saying that is the better one, or that is equivalent?
I haven't said that yet. So now, so we're just trying things out, right? We're just we're messing around, right? So so now we would go through all of the same steps for evaluating the structure again. So the first step, we always want to make sure we didn't accidentally add any electrons, right? So we're supposed to have 18, 2, 4, 6, 8, 10, 12, 14, 16, 18, good to go, right? Then we want to check on the octet rule. Oxygen here has 2, 4, 6, 8, 2, 4, 6, 8, right? But selenium now has 2, 4, 6, 8, 10.
Uh-huh.
So it has too many electrons.
Okay.
Which means that it has exceeded the octet rule.
And you can't do that.
You can't do that.
And that's why the other one is.
Yeah. And for all intents and purposes, you will see that there are some structures that can break the octet rule, but I don't make my students know them. Okay. So for you guys, you don't need to know about the ones that can break the octet. You just need to know about the ones that obey the octet.
Okay.
Okay. So your final structure, I usually will clean it up so it's not so ugly, would look like this.
Okay, cool. That is what I have. And it's a bent or angle.
Exactly.
Okay. Okay, I think that clears stuff up.
Cool.
10:30. I'm going to work on it more and I'll log on if